Hello, fellow YouTubians. My name's Terry Andrews Jr., also known as the J5 Guru. I'm down here. Okay, so I had to do this to get a wide shot of this. Today is April 4th, 2019. Okay, so this is an eccentric drive. This is one half of the eccentric drive. There is another side to this which goes over here. This goes inside the cradle base, and this power unit drives both. There's a central shaft which is coupled together to the other side, so it's the same basic setup minus the planetary gear motor and primary gear here, primary input gear here. Uh, so, what this eccentric drive is for the Johnny 5 track tip. It has to do that movement in no more than 4 seconds, and it requires a tremendous amount of force to do so because of the mechanical disadvantages um, inherent in the original robot's design. Uh, these parts here, these two parts, the eccentric arm and eccentric cam were machined by NYCCNC. John and Ed. Ed did the actual machining. Beautiful parts. This is A36 steel, and the eccentric cam is just cold rolled steel. And the fit and finish on these things are absolute. I mean, those guys just do absolutely amazing things. They're just God. They are they are true experts at what they do, and they take the time to make sure that the things are right. Yeah, it's just beautiful machining. So anyhow, I made up this very crude, very rudimentary setup. What this is I'm going to be testing the pull of the eccentric drive system. This is a big game scale. It maxes out at 550 pounds. Okay, 550 pounds for you folks in the rest of the world that go by the metric system. That is 1,210 kilograms, or 2,446 newtons worth of maximum force that this will indicate. I've tested it up to 200 pounds ish. I've hung off of it, and at least at that range, it's still accurate. So I don't have anything that weighs 550 pounds that I can put on this thing. So for all practical purposes, it's accurate-ish. Okay. So what I'm going to be doing is I'm going to be running this at an extremely low voltage, actually 1.5 volts, which is actually 16 times less because these are than the motors take, which is 24 volts. And I think you'll be absolutely amazed at the results. So yeah, this is a very don't do this at home kind of setup. This is kind of a very impromptu video. So connect my power pole connectors up. You'll be able to see this side measures current, this side voltage. Make sure I got these down. Okay, turn this on. Alrighty, so let's run this up to about 1.5 volts and see what happens. It will be very slow. It needs to be slow because if I went fast, it would exceed. I mean, yeah, things would just start flying apart, and well, the pucker factor is 11 at this point. Here we go, folks. Whoops. Go down 1.4, 1.5 right there. All right, scale's going up. We're at 100, 150, 200, 250, 300, 350. We're getting the idea yet, folks? 400, 450. They're about 6 amps, 5.7, 500, 550 right now. And I'll let it go a little bit higher. That would be like 600. Okay, there, 5.2 amps. Voltage is at 0.9 volts. I'm going to back this off. When I do, it's going to kick the power supply because of the back voltage. There we go. It's just the reverse voltage going into the power supply kicks it into, you know, I think an overcurrent thing or something. So anyhow, yeah, so let me shut this off. You can see the scale is still with the power off to the motor. As soon as this, there we go. It's still reading, what is that? Yeah, over 400 pounds. And yeah, and I can take my hand here and just go like this. There we go. Nope, not loose yet. There it is. So again, ish. It's close to zero. It's registering about 10 pounds. Yeah, there we go. There's a zero. Are you happy? So yeah, and just to show you that there's no, you know, trickery going on here, if I grab this and pull this as hard as I can, that's, I'm only getting it up to about 160 pounds there. So yeah, folks, that is at 1.5 volts, at nowhere near the current these things can draw at you know, 24 volts. Yeah, and again, that is multiplied by the fact that there are two of these. So, wow. Yeah, I designed this. Basically, I needed something that was a fail-safe. I'll go ahead and show this. I really hadn't planned to. I'll show you the actual working of it. But yes, could linear actuators be used in the robot? Yes, they can, and they were used in the original robot. Problem with linear actuators is if for whatever reason the actuator, the limit switch fails, something goes wrong, and it overextends or over retracts, it will immediately start crushing or ripping apart the robot's cradle base. There's no room for error there. There's just it. Yeah. So this Andrew Freeberg, my teammate, went into CAD and precisely figured out the exact you know, geometry and distances and things like that required to be able to get the exact linear movement of this, so that the robot inherently, if something goes wrong, a potentiometer wire comes off, a speed controller fails, you know, it just short circuits full on. All the robot will do is just sit there and go up and down, up and down, up and down. Nothing bad will happen. It'll just look incredibly silly. So anyhow, let me go ahead and plug this in and just show you how this actually works. I'll try to stay out of frame here. If I can. There, get my, yeah, maybe I gotta go over this way. Like I said, I hadn't planned on doing this. But just to give you an idea of how this works, I run this up to 24 volts. 24.1. There we go. So this, when it's normally operating, only rotates 180 degrees. For full up, from down, from track tip, tracks flat on the ground to full up. So 180 degrees takes about 4 seconds to do so, actually a little bit less. So it goes up, and then you reverse it, and it goes back down. And if something goes haywire, it just sits there and it reciprocates. It just up, down, up, down. That's all it does. All day long until someone runs over and hits the stop button. So there you go, folks. Big shout out to Tyler Hoth, who actually, I had actually kind of given up on this because of the fact that the costs were becoming, I was just like, wow, this is just getting crazy. And then, of course, having the machine in steel, which my CNC won't do. And he's like, hey, dude, he's like, I believe in you. I believe in the design. He's like, I'll fund your research. I'll fund the development. And so this is the result. I just went forward with it, and so far, yeah. And like I said, it's 1/16 of the actual motor's running voltage. It's just producing a crazy amount of pull force, push and pull force, I should say. So there we go. All right, so, and here I am, Terry Andrews Jr., J5 Guru, saying bye for now and go build something cool. All righty, and the monkey pushes the